Hello again. In this second video for the lesson, we're going to move on to learning outcome 2.4 on computing measures of spread. When we talk about measures of spread, we also need to understand percentiles, deciles, and quartiles. That's why these two are grouped together because these calculations will be used within the calculations for measures of spread. So if a measure of center captures where the middle is, a measure of spread captures how far away the values are from the middle. Why can't we just have a measure of center where we look at where the middle of the data is? And why do we need a measure of spread? Let's look at an example to show you why. So here are two small data sets. The values are 1, 2, 8, 9, and in the other data set, 4, 5, 5, and 6. So if we wanted to find the mean, assuming this is a sample data set, I would add them up. So 1 plus 2 plus 8 plus 9 and divide by the four values in the data set. This should be 20 added up together. The 8 plus 2 is 10, and the 9 plus 1 is 10. 20 over 4 is 5. So the mean is 5. If we look at the median, 1, 2, 8, and 9, this is an even data set. So to find the median, you actually have to find the average between the middle two values because it's even. Basically, what number would go here? The number that's in the middle of 2 and 8, you can compute by finding the average. 8 plus 2 is 10. Divided by the two numbers, it would be 5. So 5 is in the middle of 2 and 8. So this data set has a mean of 5 and it has a median or middle of 5. If we move on to the other data set, we have 4 plus 5 plus 5 plus 6 and only four numbers. 5 and 5 is 10 and 6 and 4 is 10. So again, we have 20 over 4 and a mean of 5. But what about the median? 4, 5, 5, and 6. Again, this is an even data set, so we'd want what numbers in the middle of these two. But because 5 and 5 are the same number, the median is just 5. So these two data sets actually have both the same mean and the same median. If we only reported the mean and the median, there'd be no way to tell these two data sets apart. But when you look at the individual numbers for these data sets, 1, 2, 8, 9 versus 4, 5, 5, and 6, the data sets are quite different. This one is quite spread out, where the numbers go from 1 to 9, and there's no duplicates. This one, the numbers only go between 4 and 6, and the number 5 is duplicated twice. They're not the same data set, but they do have the same measures of center. So this is why measures of spread are also important. Measures of spread don't only tell you where the middle is, they tell you how far numbers are away from that middle. So in order to distinguish these two data sets and actually see a difference between them, with the summary statistics, we would have to report measures of spread and not just measures of center like the mean and the median. We're going to learn four different measures of spread in this lesson: the range, the interquartile range, the standard deviation, and the variance. We'll start with the easiest to calculate, the range, which is just the difference between the extremes in the data set. You take the maximum minus the minimum. Like I said, the range is the easiest to calculate. If we wanted to find the ranges for our two data sets that have the same mean and median, for the range, you would just take the biggest number, 9, and minus the smallest, 1. So the range would be 8. For the other data set, you take the biggest number, 6, minus the smallest, 4, and the range is only 2. So right away, you can see there's a difference in these data sets. Even though they have the same median and mean, the range shows that these numbers are much more spread apart, ranging from 1 to 9, than these numbers, which are not that spread apart. They only range from 4 to 6. And that is the purpose of the range. In Excel, there's not really one formula called the range that will find this for you. You have to find the maximum and the minimum and find the difference between them. Just like we found the maximum and the minimum here and found the difference between them when we calculated it by hand. The formula for the maximum in Excel is max, and the formula for the minimum is min. So let's say we want to find the range for the time it takes to complete the Kentucky Derby. All formulas start with my equals. I would start with a max formula. Select all the times from S3 to S153, and then I would do the min again for the exact same range from S3 to S153. Close the bracket and press enter, and there's the range. So there's a range of 52.85 seconds. That's close to a whole minute between the fastest horse that's ever finished the Kentucky Derby and the slowest horse that's ever finished the Kentucky Derby. So that's measure of center number one, measure of spread, sorry, number one, the range. There's also other versions of the range. The one we're going to learn next is called the interquartile range. If you have a maximum or a minimum value that is an extreme outlier, it can make the range huge and misleadingly large. If we went back to this example, and let's say that in this data set, all of a sudden the biggest number instead of being 9 was 1,000, then the range would be 999, and the range would be absolutely huge. So outliers have a huge impact on the range, meaning that it's not resistant. So what statisticians came up with is that instead of using the maximum and the minimum to find the range, what about if you use two values that better represent the middle of the data? And that's where the interquartile range comes in. What the interquartile range does is, let's say the minimum is here, the maximum is here. So this would be the min, this would be the max. The middle number is the median. So that's the median here. What they do instead of finding the difference between the min and the max, that's the range. From here to here is your range, is they say, let's not use the minimum and the maximum in case they're outliers. Let's cut the data into a little bit more fine of pieces that we call quartiles. Quartile meaning quarter. So if we cut the data into quarters, this would be the first 25% of the data, or what they call Q1. And this would be the second 25% of the data, like the upper 25, or you could say it's 75% of all the data, and that would be Q3. It's just like quarters that you'd have for paying items. 1/4 is 25 cents. 2/4 is 50 cents. That's the middle, the median, or half the data. 3/4 is 75 cents. That would be Q3, or the third quartile. And how we find the interquartile range is, instead of doing the difference between the max and min, we do the difference between the quartiles. And we call that the IQR for short, interquartile range. That way, if you have a maximum or a minimum that is an extreme outlier, it doesn't impact the data. Because if you have an outlier that's very different than the rest of the data, by going 25% in, the first 25% of the data, you've cut out that outlying minimum and cut out the outlying maximum by only going between those quarters. To find the quartiles, you have to order the data first, just like you do the median. So the median and the quartiles are found really in the same way. Like I said, it's not impacted by outliers, so it's called resistant. However, just like the median, it doesn't use every data point. To show you how to find the interquartile range, I put a data set that wasn't automatically in order, like the one we used before with the 1s, 2s, 3s, and 4s. This one you'll actually have to put in order. We'll start from smallest to largest. So there's 2 3s, then a 4, then I see 8, 9, 10, and 12. How I find the interquartile range when I'm doing it by hand is I first find the median, or the middle value. Here there's an odd number of numbers, so it actually makes it easier to find the median. Here's the median. It's right in the middle. Then how you find the interquartile range is, for the values to the left of the median, just find the median of those three numbers. So of these three numbers on the left, find the middle of those. That's Q1. Then, for the numbers on the right, find the middle of those. That's Q3. First 25% of the data, last 25, or you can also think about it as 75% of the whole data set. Then, to find the IQR, it's the third quartile number minus the first quartile. So 10 minus 3, which would be 7. And that's the interquartile range. Like I said, it just cuts out that maximum and the minimum so that you don't have as extreme of values included in the data set because the maximum and the minimum can often include outliers. To help you a little bit more with how you calculate this interquartile range in Excel for large data sets, let's talk about other ways you can break the data into pieces. We talked about you have your max, you have your min. If you have the median in the middle, that's 50% of the data. Q1 would be 25% and Q3 would be 75%. So that's the quartiles that break the data into 4 equal parts. There are also other ways to break the data up. If you break the data up into 10 equal parts, it's called a decile. So for a decile, you'd have to have like 1, 2, 3, 4. The fifth piece would be the median, then 6, 7, 8, 9, 10, something like that. And you'd break the data up into pieces that way. Another way to break the data up is what's called the percentile, where you break the data up into 100 equal pieces. I can't really draw that one out because it'd be almost impossible for me to draw 100 little equal pieces here, but you get the idea. Instead of breaking it up into 4 pieces like the quartiles or 10 pieces like the deciles, you'd have to break it up into 100 equal pieces. In Excel, they have functions for these things. They have a specific function for the quartiles called quartile.inc. Inc means that the max and the min are included in the calculation. You put in the data set, so whatever range your data is found in, and then you put in what quartile number you're looking for. Like for example, Q3 would be for the third quartile, 1 would be for the first quartile, 2 would be for the median. A really similar formula that can do the percentiles would be percentile.inc, where you put in the data and then what percent of it you want. If you do the percentiles into 100 equal pieces, you can actually use that to find the deciles or the quartiles too. The reason for that is if you wanted like the first quartile, that would be 25%. So you can use the percentile function with 25%. If you wanted the first decile, that'd be 10% of the data. That's what decile means, 10. So you do the percentile function with 10%. So if you know how to use the quartile function, you can find the interquartile range. If you know how to use percentile function, you can find quartiles, deciles, or percentiles. It's the one that's a little bit more adaptable, that you can use it for all 3 of the different applications. So without further ado, let's show you how we can apply these functions in Excel to find the interquartile range. I'll show you how you could use either the quartiles or the percentiles for this interquartile range. If I wanted to use the quartile function, I would start with quartile.inc. That's my function for including the max and the min, which we did when we calculated it by hand. Then I'd select my data set and I have to say which quartile I want. It actually gives you the list here. The third quartile would be Q3, and then the interquartile range is Q3 minus Q1. So then I'd have to do a minus quartile.inc, select the exact same data range again, but this time quartile 1, because I want Q3 minus Q1. So there's the 3, there's the 1, press enter, and the interquartile range is about 5.7 or rounding, it'd be 5.8 seconds. Notice that the interquartile range is way smaller than the range, which is almost close to a whole minute. It's like 10 times bigger. Once we get rid of the fastest horse ever and the slowest horse ever and don't use that maximum or the min, this actually tells you a lot more about the race times that most horses seem to finish the race, or like between 25 to 75% of the horses finish the race within about 5.8 seconds of each other. Just to show you how the percentile function works instead, if I do percentile.inc, again, the first thing you do is you select the data, so it'd be the time in seconds. But instead of specifying a 1 or a 3 for quartile 1 or quartile 3, this is where you'd have to put in a percentage. So the third quartile would be 75% or 0.75, and then I would have to subtract percentile.inc, select all the data, 25% of the data, which is the first quartile. So I do quartile 3 minus quartile 1, and it gives me the same answer no matter which of the formulas I use to get that interquartile range. Okay, so those are our first two measures of spread, and we still have two more. The range just uses two numbers to find it, the max and the min. The interquartile range also only uses two numbers to calculate it, the third quartile and the first quartile. The last two measures of spread that we're moving towards use every single value in the data set, and that's why they were created to use more information. The first one that we're going to learn to calculate is the standard deviation. It's a measure of center that tells you how far every single data value is from the mean. The variance goes with the standard deviation because it's actually just the standard deviation squared. So in order to find the standard deviation, you have to know how to find the variance. And actually, if you wanted to find the variance first, you could also use that to find the standard deviation. So the two always go together. There are slightly different formulas for the standard deviation and the variance depending on if you have population or if you have sample data. For the mean, only the symbols changed, but for the standard deviation and the variances, the formulas actually changed too. So it's really important that you select the correct one. For sample data, what you have to do is you have to find how far every single individual value is away from the mean. Then you square that number and add them all together before finally dividing by the number of values in the data set minus 1. The variance is just the standard deviation squared. So once you square it, you get rid of that square root that's around the whole standard deviation. For the population standard deviation, you have almost the same formula, except you use the mu symbol for the mean. And the big change is that instead of dividing by n minus 1, you just divide by n, the total number of data values. The reason that you can do that is because when you have all the values in a data set, you actually have slightly more precision, or what's called more degrees of freedom in the analysis of statistics. For now, you don't really need to know how the formulas were invented. You just need to know that there is a difference when you subtract 1 between the population and the sample formulas for both the standard deviation and the variance. In our next example, we'll look at how you use the formulas by hand, and then we'll look at how to calculate them in Excel. Okay, so if you wanted to calculate the standard deviation and variance, and let's say that this data set is a sample data set, that's important to identify because again, if it's a sample data set, you have to do n minus 1 on the bottom. If it's a population, you just have to do n. So the formula does change and the answer will change. So before you start, you have to know if you have population or sample data. This question says sample. The first step is that you find out how far away every single value is from the mean. That's the definition of the standard deviation, how far every value is from the mean. So we need to find out what the mean is. You could use the Excel formula, average, and find out what the mean is for this small data set, and it is 7. The first step then is find out how far each of these values is from the mean. So I would take the individual value, the first one being 4, and subtract the mean. If I want to replicate this formula for my entire table, I'll have to lock in where the mean is found so it doesn't shift down into the blank areas. And that tells me how far every single number is away from the mean. Because I used every single point in the data set, in statistics, the whole goal of calculating a measure of center or measure of spread is to only use one number to accurately capture some facts about the data set. So how can I turn all of these individual numbers into one number? What they decided to do is add or sum the data set. So if I hit auto sum for this column, they add up to 0. And this actually is not by chance. This happens for every single data set you'll have. That's because the mean is like the balancing point in the data set. It's like that fulcrum on the teeter-totter or the seesaw, whatever you want to call it. So if you find out how far every single value is away from the mean and add it up, they'll always add to 0. So that kind of stumped statisticians, or it can stop you rather, and say, okay, I found out how far every value is from the mean. I tried adding them up so that I had only one single number to represent how far they all away from the mean, but it will always add to 0. So what can I do so that they won't add up to 0? And the answer was, if you got rid of the negatives on these numbers, then they wouldn't cancel out and add to 0. So one way you can get rid of the negatives is to square. By squaring the values, just multiplying the number by itself, it will turn it into a positive value. So when they're all positive, they can't cancel out when we add them together. So I'll take my first value and square it. To the power of 2 is how I can do the squaring in Excel. From there, just drag the formula down so it replicates. And I get every single value individually squared. Now that there's no negatives, they can't cancel out. And finally, again, I'll add these up. Now, I get a sum for how far every single data point is away from the mean, where they don't all cancel each other out. And that's this part of the formula, the top part that says take every value, figure out how far away it is from the mean, square the values so they don't cancel out, and then add them all up. The last thing I need to do is divide this by n minus 1. The sample size for this data set we can get using the count function in Excel. That there are 7 values in this data set. You could also just manually count them, but when you have a really big data set, you wouldn't want to count them all individually. So that's why I use the count function in Excel. Then for the standard deviation, I'll just implement the formula that it's the square root of everything we added up inside the table divided by the sample size minus 1. So here's the 80, everything we added up in the table, divided by the sample size minus 1. I use brackets just to make sure that the order of operations is done correctly. And I get 3.67 approximately. The variance is then just the standard deviation squared. Or if you look at the formula directly, it's just the total from the table divided by the sample size minus 1 with no square root around it. That's the variance, which is about 13.33. So that's how you calculate the standard deviation and the variance using the formulas. You don't have to do it this way because there are built-in formulas to find the standard deviation and variance for you in Excel. I just always like to show you how to use it at least once because I think it's important to have an understanding of the formulas and why we square them, why we have the square root and no square root, and how that impacts the calculation. And we'll also talk more next about sample and population differences in the formulas. Okay, so because this is a long process using the formula method, the functions in Excel will be a lot faster. But before you can pick the right function in Excel, you need to know if you have sample or population data because, again, the formulas are different. If you have an n minus 1 or an n for the population or the sample data. So first step is to determine what type of data you have. If you have sample data, you'll use stdev.s for the standard deviation, where stdev stands for standard deviation and the s stands for sample. If you have population data, you use stdev.p, where the p is for population. For the variances, you use the formula var with a .s for sample data or a .p for population data. So we're finally ready to try out these formulas, the fast way of using them, for our data set on the Kentucky Derby for time in seconds. For this data set on the Kentucky Derby, to know which formula to use, first you have to determine if you have population or if you have sample data. The Kentucky Derby has been run since 1875, and if you look at this data set, we have every single year since that time, since 1875. Even during COVID, the race still continued, even if it didn't have people actually attending in person. So we have a winner every single year. Because we have every single year, this is not a sample. This is population data that we have for the Kentucky Derby race times. For that reason, we'll have to use the version of the formulas that has .p on the end for a population data set. So for the standard deviation, I'll start with stdev.p, and then I'll have to select all the race times. Whoops, I clicked outside of the formula by accident. stdev.p, open the bracket, and then select all the data for race times. And that's it. This will give you the standard deviation for the population. It's about 12.669 seconds. For the variance, I could either take this number squared, that would be the variance, about 160.5, or to actually use the formula, it would be var.p. Again, because we have a population, we have every single value, every single year the Kentucky Derby was run, var.p, and select my data and press enter. And again, it would give me the same number, 160.5, but I calculated it with the actual formula rather than just taking the standard deviation squared. So those are our 4 different possibilities for the measures of spread. We did the range, the interquartile range, the standard deviation, and the variance. The final thing in this learning outcome that I wanted to talk to you about is just a quick summary. The range, the standard deviation, and the variance are calculations, so they all need numbers to find them, so they only work for interval or ratio level data. The advantage of the range is that it's easy to calculate. The disadvantage is it only uses 2 numbers. The same thing is true for the interquartile range, that it only uses 2 numbers. So this is range and interquartile range, either of the ranges. For the standard deviation, it uses all the data points, so that's a really good thing about it. But the bad thing is it's not resistant. That means if you have a really big or a really small value, it will be impacted by the outliers. Again, the same thing's true for the variance. It uses all the data points, but again, it's not resistant. Another bad thing about the variance that I didn't mention before is that it isn't measured in units squared. So because we took the square of the standard deviation value, that means that the variance would be measured in seconds squared, which is a weird unit to have. And that's why we typically don't prefer to work with the variance, because it's measured in the units squared. So if you had dollars or data that was captured in dollars, then the variance would be measured in dollars squared. And what does that even really mean to have dollars squared? So if you work with the standard deviation, it's measured in the original units like seconds or dollars. So it's a lot easier to interpret. So you can even add that to the disadvantages as well, that it's measured in the units squared. And that's it for our summary of the measures of spread. Please go to the next video where we will talk about visualizations for quantitative data.